Awesome. I think we are live. Beautiful. Welcome, everyone. We'll just wait a couple of minutes for people to trickle in. I guess we can get some conversation going. Akshit, how has your day been so far?
It's been pretty good. I had to attend my classes and after that work on a little bit of modding, and after that I just took a little break.
Sounds good. What do you like doing outside of work or school?
Generally, I just like making open source projects and just making fun stuff.
Yeah, absolutely. That's why you're here. Giving you that
Yeah.
platform to share it with the world. Hello, everyone. I can see we have a couple viewers now. Welcome to our second Maker Spotlight session. I guess we can get started. So, thanks everyone for joining. This is our second Maker Spotlight session, and this is a series of events that are live streamed to our socials, where we allow our talented community members to present their amazing Cohere powered projects to the rest of our community. We have this going on LinkedIn, Twitter, Twitch, YouTube, and Discord. So make sure to check them out. Make sure to interact. And welcome. My name's Claire. I'm the developer relations intern here at Cohere, and I'm here with Akshit Ireddy, our amazing community ambassador. And today we're going to be helping and presenting his demo on Interactive LLM Powered NPCs. And so with this project, it's super cool. You're able to interact with NPCs, have realistic conversations, and speak with them through your microphone. A lot of cool stuff happening here, and it's mainly powered with a lot of Cohere language models and our embeddings. So, without further ado, we can hand it over to Akshit, and we can begin.
Hi everyone, I'm Akshit, and so today I'll just show you my interactive LLM powered NPCs project. So let me share my screen. Yeah, so my project is open source, so you can, dive into the code right here. But before that, let me just show you a demo of how it works. And after that, I'll show you the GitHub repo and also go into the code. So let's start with the demo. So this is a recording of the demo. So generally what happens is you'll have to launch the game and then it creates a new project window with, and that project window is the window through which you can interact with the NPCs. So let's first see the window, the demo.
Rogue, do you like ice cream?
Ice cream? Are you trying to sweet talk me, kid? Well, I won't say no to a good scoop of vanilla if that's what you're offering. But remember, I'm not here to discuss frozen desserts. Stick to the point or you'll find yourself on the wrong end of my boot. Got it?
So if you're wondering how this works, it basically does not alter the game.
I think we lost Akshit for a second. Sorry about that, guys. I think we can try to get him back on. Until then, I think we're gonna have to wait. Thanks everyone for your patience. Awesome. He's back on. Let's continue. Thanks everyone.
Okay, it seems like I disconnected. Where did I stop?
Yeah, you disconnected for a bit.
Okay, so
And
was I
so,
at the GitHub repo?
yeah, you can continue where you stopped.
Okay, yeah. So yeah, so it analyzes the frame and detects which characters you're talking with. So let's say you have a frame like this. So basically it first detects the faces inside of the frame, and after that it determines whose face is closer to the center, and then takes your voice input and.
What can I get you?
What's the best drink you've got?
Well, darling, in Night City.
And you'll notice that the character is speaking. So it that's how it works. And if you you can use it in a different number of situations. So, like over here, and it's not only for face-to-face conversations. So you can also use it when the NPC isn't visible. So let's say you're horse riding, like in a situation like this. So in a situation like this, you can't see the NPC's face, but you still want to engage with them. So in these type of scenarios, then the project will generate an audio response and play it to you. So let me just show you. Yeah.
Since when have the Straw Hats been short on food?
We've been low on food since the invasion, and what little we had was stolen by some greasy merchant.
And it also works in if you're sailing a ship, and the NPCs have unlimited memory using Chroma DB for vector stores. And again, this is since it does not involve altering the game source code, it can work with almost any game. If you want the NPCs to respond to you as realistically as possible, like uh, like technically, this can work with any game, but if you want the NPCs to respond realistically to you, like how they would inside of the game, then you'll have to make a separate folder for that game, which I'll go into once we get into VS Code. But for now, let's move on. So for the LLM, it uses Cohere's command model, and it also uses an embedding model for the vector stores. That's also Cohere's. And so once it generates the text response, that is converted to speech. So for generating the speech, it uses HTTS, but it's fully customizable. So if you would like to use any local model that you have, or something like 11 Labs, that you can do that as well. And once you have the speech, it generates the facial animation using SAT Talker. You might have heard of it before. If not, I'll show you that in the VS Code. So basically, that generates facial animation from audio and the NPC's face, and once it generates the facial animation, it overlays it on top of the NPC in the frame. So let me just show you what I mean over here. So this is so it first extracts the face of the NPC. After that, it generates an audio response, and it combines those two to form a facial animation video. If you notice, our lips are moving. And so once you have this facial animation video, you can overlay it on top of the frames in these coordinates. And so it will appear as though the NPC is talking to you. So basically, it opens another project window. So you have the game window and the project window, and you'll see the facial animation with the audio response in the new project window. So let me just head back over to the, So it works even if the NPC's face is invisible in like horse riding or sailing, like I told you, and it's compatible with any game. So let's move into VS Code now. So basically, each game has a game folder with a folder for characters, NPC personality creation. So this folder is mainly for the background characters, the civilians moving around in the city. So you can talk to the civilians as well. So let me just show you that. Not only side characters, but you can talk to the civilians as well.
Amidst the concrete.
So you can talk to them more here. So for these characters, since they're they don't have a personality or a name, the project basically has to create a name and a personality for them, which I'll go into later. But for now, let's look at this folder. So there is a text file called world.txt. This file is basically the text over here is passed on to the prompt. So, so that the LLM has a little bit of context about the game. And this is public info. So basically you add all the information that any person living in that game world should know. So you can think of this like basic knowledge that anyone living in that game world is supposed to know. And now I can't, if you'll notice, it's, thousands of lines. So I can't directly add this into the prompt. So for that, what I do is I basically create a public vector database that every NPC in the game has access to, which is over here. And you can, create that using this Jupyter notebook. And let's, yeah, so you'll also have a character folder. The default folder is for background NPCs. So, the NPCs that don't have a personality or name or backstory. So if you'll open up this, you'll see, yeah, so the project automatically, the project first looks at the face of the NPC and it determines, the gender, race, and age. And based on that, it generates a bio, name, and also it selects a voice. So once it's done selecting all of that, so another thing is, if you'll notice, like the NPCs in every game, like let's talk about Cyberpunk 2077. So the NPCs in that game are not going to talk like us, like they're in the future. So and they're going to use different kind of words. So if you'll notice, there are words like cred sticks, choom, and different kinds of words over here that aren't typically used. And if I directly integrate the LLM with the NPCs, the responses aren't going to be realistic. I mean, for that game. So for that, I created a JSON file called preconversation.json with a couple of lines that are used inside of the game. And then whenever it generates a response, I randomly pick 5 to 6 lines from this and inject it into the prompt. So that way, I don't need to fine tune every model for fine tune a model for every game. I can just create a JSON file, and then every time it generates a response, I can just randomly pick some lines, put inside the prompt. So it's done all automatically inside of the code. And so this is basically for just guiding the talking style of the NPC, without having to fine tune the model. And that's for the default folder. And you'll notice something called voice. So this is basically responsible for creating the voice response. So it has a function called create speech. You can modify this to use any other service or local model. And this is the default character. And let's look at side characters. So basically side characters, they tend to have a backstory, name, some memories that they might have had before, before meeting the player. So we put all of that information in bio.text and character knowledge. So bio.text is directly injected inside of the prompt every time this character generates a response, so that the LLM knows a little bit more about the character. And as for the character knowledge, this time it's just 40 lines, but it might not be the case for every game. So that's why we'll have to create another vector database over here for the character using this Jupyter notebook. And you can create so this vector database you can access memory for the NPC. And again, this every character has a different talking style as well. So you can go inside of your game's dialogue script and grab a couple of iconic lines of that NPC, that side character, and just put it inside of here. And just same like default, it grabs a couple of lines from over here and injects it into the prompt every time your side character generates a response. And you'll notice an extra folder here called images. So that is basically pictures of the NPC. So this is used to create something called facial representations. So that is created using this Jupyter notebook. So the reason that this is there is because when it analyzes the frame, yeah, so it's basically looking at the character, and it grabs the character's extracted face and then runs it through every character's facial representations and determines which character this character is similar to, and then determines the character name. So that's how it figures out which character you're talking to, and then uses the according vector DB and bio and etc. So that's how every game folder is built. And let's also just go through the main IPYNB. So this is the main notebook. So every time you want to run it, just use it in your games. Just set your player name, game name, interact key, and facial animation switch. And you can just hit run all, and it will create a new window. You can just pull that window into another display and run your game on your main display. And that project display will basically mirror everything that's happening in your main display. And when you want to talk to the NPC, you just have to click on your project window and hold down the T key and just speak. And then after that, the NPC will respond to you. So you'll also have to set your monitor's width and height. And after that, so let's look at the code here. So for every, so it's basically a while loop that grabs your screen every second. And so all of these variables, speak, display, transcribe, text, display is all false at the beginning. So every time it's going to just wait for you to press the interact key. And if you press the interact key, then it's going to set speak display to true. And when that happens, it basically means that it's waiting for you to speak. So once you speak, it's going to grab your response over here if speech recognition start. And once it does that, it just shows you what you spoke, and then after that it starts the main function. So basically, this main function is responsible for overlaying the facial animation pixels on top of the frame window. This piece of code over here, it basically replaces the ROI in the image with the frame. And let's look at the main function over here in functions. Main. Yeah, so there are four ways this can go. Either it's a background character or a side character. And for the background character, the face might be visible or might not be visible. So if it's visible, then you're going to generate the facial animation and then overlay it on top of the character. If not, you're just going to generate the audio. Same for the side character as well. And another interesting thing is every time you speak to the NPC, the webcam takes a photo of your face. So after it takes a photo of your face, it then runs webcam photo emotion predictor that basically just detects what emotion your face has when you're talking to the NPC, and it passes that emotion value to the NPC so that the NPC knows what expression you're keeping, so whether you're happy or sad. So that can help the NPC in giving you better responses. So again, for the emotion detectors and age, gender, race, and all of that, I'm using deep face. So it's a pretty good package. And yeah, so you can see, so this is the audio generation part, and this is the facial animation generation part. So let's look at, and I also told you that it generates a unique personality for the NPCs. So that part is controlled by this create personality. So now every game, let's say you're playing Cyberpunk 2077, then the NPCs over there are going to be futuristic. And let's say you're playing Assassin's Creed Valhalla. In that case, then the NPCs are going to be really old and old-fashioned, and so depending on which game you're playing, you're going to have to modify this. So basically, this template has a couple of names and what kind of personality they will have. So it basically has 3 examples, and then it takes a name and then initializes the LLM and then just gets a response for a unique personality. And this is for the audio mode because this is the audio mode because this is the audio mode, and it also has a video mode create personality. If you notice over here, it has stuff like gender, race, age as well. That isn't there over here because the face isn't detected. And in situations where the face is detected, it also uses the gender, race, age variables to create the personality. And let's move back to the main file, right? So if you're wondering how the responses are generated, let's go into one of them. Let's say this one. Yeah. So every time it's generating a response, it first gets a couple of lines that are specific to that character. So I showed you the pre-conversation file. So the pre-conversation loader basically just randomly picks a couple of, it first shuffles the lines and then picks a couple of lines from the pre-conversation file to, help the talking style of the NPC be as realistic as possible. And then just, we store it in this variable, and also the conversation. So we have something called conversation as well that basically stores the conversation that you're having with the NPC. So once it gets too big, it's going to summarize it and then put it inside the vector database. You can see that, yeah, it's going to put inside the character vector database whenever this conversation gets too long. I think the limit is 500 for now, but if you can increase it if you want to. And yeah, so that is the conversation string, and the bio string is basically the bio of the character. Information about that character, who that character is, and some information about him. And we also have something called world string, which is the world information, and public data string. So what public data string is, it uses a function called get public data. So now that function is So what it does is it looks at the last 5 lines of your conversation and then goes into the vector database and finds information that might be relevant to your conversation, and it stores it over here. And character data string is, like say you want to ask the character about themselves, like what do they do? Then in that case, you're going to have to look inside the character data. So for that, you're going to use this function, which is pretty similar to the get public data. It looks at the last 5 lines and grabs information from the vector database that might be similar to the conversation, and stores it over here. And yeah, for the embedding models, it's using Cohere's embedding models over here. And so once it has all of this information, it then just initializes the LLM and creates a template string with about the game, the world, character name, bio string, character's name, and all of these variables, including the emotion of the player. And it's formatted into a prompt sent to the LLM, and you get a response. So this is a text response, and we also just add it to the conversation. And after that, you have a text response. So you're now going to have to convert it to voice. So for that, what we do is, since we're going to use a unique voice for every character, we're going to have to create a Python script that basically references that character's voice. So basically, voice.py. So it basically looks at the game, the character name, voice.voice, basically this one, and it imports the create speech function and creates an audio file and saves it to over here. And after it does that, it just runs the file over here with subprocess. And once it's created the audio, it's going to
What's that?
Yeah. So once it creates the audio, then it's a time for facial animation, which is done using create facial animation function. So let's look at that function as well. Yeah. So this function takes the audio path and video output path and the image path. It uses subprocess and sat talker. So this is basically sat talker. So it uses this package. It's a GitHub repo that you can find it online and use it for different use cases as well. And so it basically sets this command and runs this, and it saves the video files to this folder, and it then moves it over to temp over here, this video file, and then deletes everything in this video temp folder. And once that is done, you basically now have the facial animation path and audio path, and that's all you need. So you can see that it returns the facial animation path, with audio path, and the coordinates of the character. So you're going to need the coordinates of the character because you're going to have to overlap it over those coordinates only. So that the coordinates are also important. So this is for situations when the face is invisible. So it's just going to play the audio and then it's going to stop working. I mean, it's going to basically just go to the next frame and wait for you to speak again. And yeah, and if you have a video path, I mean, if facial animation is generated, it's going to load in the coordinates, get the frame. And once you get the frame, just get the FPS of the facial animation and start playing the audio. And while the audio is playing, you overlap the facial, the screen with the facial animation video using this code, and it runs until the facial animation video is done, and then it just releases the video, releases the audio thread, and after that it just it finishes running and waits for you to talk to it more, or if you if you want to close it, you just have to press Q and it will close the window. So yeah, and yeah, I think that's about it. I mean, a really short way of overview of how the project works. So
All right. Actually, thank you so much for this. That was a sick demo and a really thorough overview of it. By the way, folks, I'm Sandra. I'm looking after community at Cohere, part of the DevRel team here. We want to follow up with a Q&A session. So folks, if you're watching right now and you have any questions to Akshit, please let us know in the comments. We're gonna take these questions live on stage. Meanwhile, I have a couple of questions. This is one of my favorite generative AI demos that I've seen in a while. It was mind-blowing to see how many things you managed to package inside of this one single project. So I wanted to start by asking basically about the journey of creating your demo and sort of the motivation behind it, because it's really rare in my experience that you come across demos that are using LLMs, but that are also using transcribed text to speech, facial recognition, so many other cool things. So how did you even start thinking about putting it together?
So originally, I mean, I've always wanted to, add LLMs to the NPCs in Cyberpunk because, the game was really realistic, but it just lacked that conversation aspect. I think I had that idea about 2 years ago, but it just felt, at that time, I wasn't too familiar with LLMs, and also modding the game directly also felt like a challenge. But, as time moved on and tools like SatTalker, Deepface, a major part of why I was able to do this was because of these, open source tools like SatTalker, Deepface, HTTS, Cohere, ChromaDB, and so many more tools that helped me build this. So, and as for why, because if you want to add this feature to every game, you'll have to mod every game separately, and it's going to be complicated. So at that point, I realized that maybe there's a way to do it without altering the game source code, and it's compatible with almost every game possible. And that's when I thought, what if I just grab the frames of the game rather than alter the game source code or do something like that. And and I also saw a demo from with basically a YouTube video called it was basically a Conway demo with Matt Wolf. So I got a lot of ideas from that video as well, like using vector databases for the characters, for the world. So that helped me a lot.
That's amazing, fantastic demo. I'm really excited about this, and that we have you here and we can learn from you. So can you tell us a little bit about these open source and not open source frameworks that you decided to work with? I understand that the access was easy, but were there other reasons perhaps that you have chosen these over other ones? And what was your experience while you were putting it together?
So for the LLM agent, I used LangChain with Cohere and Cohere's command model. So previously, I used to use the Cohere's extra large beta model. But for this project, I needed a little bit more context tokens because I needed to store the pre-conversation, the character information, but also I needed more context tokens. So the extra large had about 2,000, and I noticed the command had 4,000, which was perfect for this project because I needed as many tokens as possible. And for the speech recognition and text to speech, I used HTTS a lot, and the voices are, they're not perfect, but they're a good starting point. And for people who want more realistic voices, they can always use something like 11 Labs or anything else. And for the vector DB, so my options were Pinecone and ChromaDB, but I thought, the vector DBs usually don't take up a lot of space. So I thought, why not go for a local vector DB instead of something in the cloud?
Got it. Very inspiring. Thank you so much for running us through this. We have a question coming from Jay Alamar, who's asking, what improvements do you envision for the project? What's next? Which was also my question, by the way.
Well, I've always wanted to try to, like this project can control their facial animation and their responses, but it can't control their actions. So I'm still not sure on how to control the actions of the game because I'm not altering the game source code. So that would be pretty interesting because now you can if you could control their, like you could speak to them and then say grab this cup for me and give me this cup. That would be pretty cool, but I'm not really sure on how to implement that right now. Another request that people have been asking is to use local LLM models, but I don't think that's possible right now with how GPU intensive they are and stuff.
While we're on that topic, actually, Jay has another question asking about how do you run it? Do you run it in the cloud? Do you need a local GPU?
Yeah.
What kind of setup is needed to make it work?
The most intensive thing is the facial animation generation part. The rest of the stuff like text-to-speech, speech recognition, the LLM agent is all in the cloud. So just the facial animation part is done on the GPU. So I've tested it with the RTX 2060 and an RTX 4080. So it takes a little bit more time on the 2060, but it works. And on the 4080, it's a little faster.
Gotcha. Okay, so I think it's worth noting as well that in those cases where you would like to, follow up and create more code for the project, but you're not exactly sure why, your GitHub repo is open source. It's open to anybody for the pull requests, so please send them over. Exactly, that's the next question coming from Greg. Is it open source and are you sharing a GitHub link? Yes, we are. Let me grab it for you. And meanwhile, could you also tell us, why did you decide to venture into the gaming space? Why a gaming use case? I understand that you're interested in games generally, but it's a pretty, I guess, like hardware intense and also like pretty intellectually intense use case to start with because you have so many elements, so many moving pieces.
So before this project, I did something called GPT-4 Plays God of War. And so basically that project was, it used Coheed's LLM with YOLO V8 to basically detect where the enemies are, and then the LLM would decide what kind of move to use. And that was pretty fun for me. So I thought, what could be better than this? And that's when, the cyberpunk idea came into me.
That's really cool. I love some cyberpunk myself. So do you actually like use it? Do you,
I haven't been
spin it up
gaming for a while because I'm a little, I've been a little busy, but I did use it a lot while testing and it was pretty fun.
Nice, that's awesome. That's awesome. Folks, if you have more questions, this is the final chance to come and ask them. Meanwhile, I want to share the GitHub repo that Akshit is working on. So please go and check it out. And also please contribute. And if there are no more questions, I think we can wrap up for today. Actually, thank you so much once again for showing up and for giving us a rundown of how your project works and how you have put it together. shout out to your project, that it's open source, and that hopefully we can leverage the power of community to make it grow. Yeah, and for folks, thank you for joining us. See you next time.
Thank you for having me.